Locate local and absolute extrema from a graph. Locating extrema graphically. So let's take a look at some examples where we just find and locate the absolute and local extrema of a particular graph. So here we're given a graph of this function, and we want to find, or excuse me, identify the absolute and the local extrema of it. So let's first start off with finding the absolute extrema being the highest or the lowest point of a particular function. And we can see here that at x equals -1, y equals 6, this is the highest point on the function. So that means we would have an absolute max at at the point -1, 6. Now, as we can see, our end behavior here in both sides goes towards -infinity, which means that there is no absolute minimum value. And just going back to what we learned previously, we can't apply the extreme value theorem here, because while our function is continuous, it's not on a closed interval. It's on the open interval -infinity to +infinity. And then we can come and we can identify our local maxes and mins. We can see here that we have a peak, so that would be a local max at, let's see, -6, 3. We can then see that we have a valley right here, or a lower peak, so that means we would have a local minimum at the point -4, -1. Then we have a peak right here, and this would be a local max at -1, 6. And now there's nothing to say that a local and an absolute max can't be at the same point, because by both of their individual definitions, they both qualify to be an absolute max and a local max. So yes, absolute maxes can be local maxes can be absolute, and vice versa for absolute minimums. Absolute and local minimums can be the same point. We also have a local minimum at this valley here, so this would be at 2, -7. And then we have our last extrema right here. This would be a local maximum at the point 4, 1. And there we go. We have now identified all of our absolute and our local extrema. Alright, so let's take a look at another one. Here, we want to locate the absolute and local extrema of this particular graph. So just like before, it's easier to start out with the absolute maxes and the absolute mins. So we can see that we have a highest point right here, so we'd have an absolute max at the point 0, 6. However, we can see here that we also have an absolute max right there, because it has a shared y value of our first absolute max. So we're going to have another absolute max at the point 6, 6. Alright, and similarly to our previous graph, this example has end behavior that goes towards -infinity on both sides, so therefore there is no absolute minimum. Then we can check local max and mins. We have a peak right here and a peak right there, so that means we would have a local max at the point 0, 6, and we would have a local max at 6, 6. So just like the previous problems, our absolute maxes and our local maxes can be the same point. But that means we're then going to just have one local minimum value at the point 4, 1. And there we have all of our absolute and local extrema. Let's take a look at one more graph. Same directions, locate the absolute and local extrema of this particular function. So, just like previous examples, we want to first identify the absolutes, because those are the highest and the lowest points. But we can see we have one end behavior going towards positive infinity, another end behavior going towards negative infinity, which means that there are no absolute extrema for this particular function, so it's all local. And we know locals exist at peaks and valleys, corners and cusps. In this particular function, we only have peaks and valleys. So let's see, we're going to have a local or a relative min at the point -5, -2. And we're also going to have a local minimum at the point, 3, -5. And we have a local max at -1, 7, and a local max at, what's that going to be, 7, 7. And there you have it, all of our local max and mins for this particular function. Alright folks, that is it, locating local and absolute extrema from a graph.